very familiar with you, and he has a tremendous work to our chemistry also. J.J. Thomson measured the ratio of electrical discharge. What he has measured? The ratio of, what is a ratio of electrical discharge? Any electrical discharge if you take, it has a specific charge. This charge generally measured to the mass of an electron. What will be the mass of an electron? Every electron contains a subatomic particle contain specific mass. By using cathode ray experiment, there is an experiment called cathode ray experiment, or tube. Specific tube is taken here, a cathode ray tube, applying electrical discharge and magnetic field. So a magnetic field is taken with the north pole and south pole, as you know that, and they are perpendicular to each other, which means the electrical discharge is perpendicular to magnetic field, which is mentioned in the main path of electrons. So what will happen finally when only electric field is applied? Simultaneously, electrons are going to be deviate from their path, which means they change their path and moves towards another direction and hit the cathode ray tube at a specific point. In the diagram I will show to you. Similarly, when magnetic field is applied, electrons generally strikes the cathode ray tube at a point C. Imagine this is a point C. Here I have a point C and point B is here, imagine. So what does it indicates? Whenever these two fields are acting upon a specific what we can call cathode ray tube, specifically they change their path by carefully balancing electrical and magnetic field strength. J.J. Thomson successfully bring back the electrons and their path to their followed in the absence of electric and magnetic field, and they hit the screen at a field B or screen point B. Thomson argued that amount of deviation of particles from their path in the presence of electrical and magnetic field depends upon the specific path. You can see here, this is a magnetic field. What is that? I am just labeling the J.J. Thomson experiment, which demonstrate electrons are going to change their path based upon the electric field. When it is applied, it has a different path and motion. When magnetic field is applied, it changes path towards a specific direction. So this indicates they have a different motion and they have a specific velocity. Okay. Finally, charge to mass ratio of electrons describes that the field or electrical field or a magnetic field, anything, whatever it is, it changes the direction of a electron because the specific charge. Why? Because electric field contain a specific charge to mass, isn't it? Whereas magnetic field contain a specific what we can call force, which is going to be exerts on the electrons. So based on this we can understand charge to mass ratio of electrons by magnetic and electrical field demonstrated by the J.J. Thomson. So in the coming video I would like to explain one more topic that is relevant to magnetic and electrical field in case of electron motion or electronic motion. In case of magnetic field, if you see in this experiment, before going to conclude this video, if you take the magnitude or the negative charge, magnitude or negative charge of negative charge which is going to act on the electrons, okay, in case of greater magnitude of the charge on the particle, whatever it is, or less than the or less amount of magnetic field, or greater in the interaction with electric and magnetic field. So here Based on these forces or magnitude of the negative charge on the particle or greater the magnitude of the charge on the particle, greater is the interaction, which means whenever that fields and forces are increased, the interaction of a specific electron or electric or magnetic field, thus here deflection will be also going to be changed and it will be greater in case of this experiment. Finally, thus mass of the particle, lighter the particle, greater the deflection, which means whenever the mass of the particle, which means if the mass of the particle like electron is lighter, then the deflection will be more, which means deflection is nothing but opposite to reflection. The strength of the electric and magnetic field having specific force, the deflection of electrons from its original path generally increased or increases with the increase in the voltage. Whenever the voltage increases, generally electron from its original path also going to be increased by its voltage across the electrodes, okay, or the strength of the magnetic field, etc. Here I have some values that you have to learn. E by ME, electric field by ME. By carrying out accurate measurements on the amount of deflection takes place by electric and magnetic field of the particle, the electrical field strength or magnetic field strength, right, whatever it is there, Thomson was able to determine the value of E by ME is equal to as 1.758820 into 10 or 10 to the power of 11 coulombs per kg inverse is the value given by the J.J. Thomson. Okay. Finally, charge on the electron, how much it will be